On last class, we talk about the first function that was a PMT function in the series. Okay, you can see that we can use the PMT function in order to find the payment. One thing that you always have to be careful, because like from last class, I just like noticed that okay, one thing that some of us may have like may forget about it is about the time, or I mean the period of time that you also have to just like pay. Okay, one thing that you have to be careful is about the rate, especially if we talk about the quarterly basis. Bear in mind that normally the interest rate that the problem should always like bring it up is percentage per year, or it might be like, let's say 5% per month, something like that. So the things that you have to do is that if you get the rate per year or rate per month, firstly, think first, how frequent do you have to pay per year? In this one, you can see that if it is monthly payment, you have to convert the interest rate from yearly to monthly. So that means the rate that you receive must be divided by 12 in this case. But on the second example that we had on last class, you can see that the question or the problem said that it's a quarterly payment, and the interest rate is 3.5% per year. That means you have to always change the rate to be from rate per year to be the rate per quarter. So that means, for example, in here, if the rate is 3.5% per year, if you want to change it to be quarter, let's imagine that this circle is a year, okay? And then when we need to have a quarter, we have to divide the year by 4. Same as this one. It must be 3.5% by 4 as well to get the quarter rate, the quarterly interest rate. Okay. So it is not divided by 3. It is not multiplied by 4. Okay. So just think about it, because quarter is smaller than year. So that's why when you have to just like calculate the interest per year to be interest per quarter, you have to divide by 4. Okay. Right. Okay, then let's come back to talk about the next function that we have to know. After we talk about the first function PMT already, the next function is what function that is what we call FV, or future value. Let's see the future value or FV function first. For the FV function or future value function, if you have a look in the formulas, okay, we go to formulas, financial, and then we just like find the FV here. You can see that for the explanation of FV, you can find it here. So this one is, I mean, Excel tries to just like give you the help as much as it can. For example, in this one, it shows you the description of this function. Function FV, or future value function, is a function that Excel will return the future value of an investment. Okay. For this calculation, we still based on periodic constant payments and constant interest rate. As I told you earlier, that we need to have two assumptions when we use this series of functions. The first one, the payment must be equal on every time you pay. That is constant payment. Constant interest rate means that for the whole contract period, you have to pay with the same constant or just like fixed interest rate. Because if they just like say that okay, the rate will be divided into two different rates. For example, if the loan contract is divided to 4 years, and they say that okay, for the first 2 years, interest rate is 5%. Okay, and from year 2 to year 4, interest rate is 5.25% per year, something like this. If the interest rate is varied like this. The trick is that, okay, in this class, okay, we don't have like up to like the details like many rates like this, but in the future, if you see the problem like this, the things that you have to do is that you divide the time into two periods. The first period, you calculate the first 2 years first to find out the interest, to find out the future value of the second year. After that, the rest 2 years from year 2 to year 4, you just like calculate it once again. But right now we just like use different rates. So you just divide the timeline to 2 periods in this example. Okay, then right now just come back to the FV function. For this FV function, we still need to use like 5 arguments similar to the PMT function, but the order of the FV function is different because FV start with rates, number of period or n per. Okay, we need to have like the PMT or payment per each period of time. PV or present value of money, and type means that, okay, when would you like to pay? Okay, so that means, okay, 0 if it is the end of the period, 1 if it is the beginning of the period. Okay, so it depends on the problem that you receive. Okay, so now I'll start with the first example for the FV. Okay. For the first example of the FV function, I'll just like copy it for you. Okay, the problem is shown in it already. Okay, please copy. Okay, so in this one, okay, I'll just like put all of the required argument first. We have rate, we need rate, n per, PMT, PV, and type. Okay, you can see that in this example, okay, we need to find the future value. Okay, so if the assumption is met, the future value here, we can use the FV function that needs these arguments. Okay. Right now, this is investment. Okay. We would like to invest $1,000 per month over 5 years. So, investment of 1,000 per month in here means that you want to just like pay, okay, $1,000 per month. So pay means that if you would like to pay, it must be at PMT. Okay, it's a payment. And when you say that you would like to pay for the investment $1,000, or if you would like to pay back to the debtor, okay, the money is out of your pocket. So bear in mind that the symbol of the payment here must be negative 1,000. Okay, so we put negative 1,000 for the payment here. After that, the next thing is that we would like to pay per month 1,000 per month over 5 years. So now from this phrase, we know immediately that this one, it tells us about number of periods that we have to pay. So when it is monthly over 5 years, it is 5 times 12. Okay, it's 5 times 12. Okay, as the number of periods. So in this one, it's equals to 5 times 12. Somebody may ask me that, can I use 60 straight away? Yes, you may. But in my example, I just like want to show you in detail how do we obtain 60. Okay, present value 0, it tells us already, so the PV is 0. Interest rate is 5% per year. So once again, even the interest rate is 5% per year, but we pay monthly. Then you have to change the interest from per year to per month as well. Okay, you can't leave it as 5%. So if it is monthly, okay, that means because monthly is shorter than year, then you have to divide 5% by 12 to make it become the monthly rate. So in this case, we just like put the rate to be 5% divided by 12. Okay, divided by 12. So the things that you may do, some of you may say that, can I change it to be percentage format? Yes, you may do it. Okay, but be careful if you just like do the formatting here. Okay, by clicking on the home tab and then in the number group, you click on percent. It seems to be 0%, but actually it's not. But it has decimal points. The thing that you have to do is that you increase the decimal points to see the real percentage of it. Or you may leave it as the real number as 0.0041667, something like that. So both of them are okay. Next, the type we pay at the end of each month. The type is 0. Okay, the type is 0. After that, we put them in the function. So in this one, okay, I just like click on FX, okay, and then type FB as I want. Then I just click OK, and then I start entering all of the arguments that we have. Okay, so right now, okay, you can see that in here. If I just like, before I click OK, you can see that in the formula builder box. This one, in this box, or in this Windows, we call it as formula builder. Okay, it just asks us for the function argument, and also it shows this. This part is what we call intermediate results. Intermediate results. So the intermediate result for this example show us for positive $68,006.08. Okay, so what does it mean? In this one, when the result show us for the positive value, it means that, okay, the future value will be positive numbers. What does it mean? It means that if it is positive, we have the money in our pocket. So that means this is investment for sure, because at the end of 5 years, we have the money. Okay, the money will be with us. So that means this one, okay, $68,006.08 is the investment that we will receive after we just like finish the period. So on last class, some of you asked me that how do I get this number? I put the number on the right hand side of the calculation here. I told you that I just want to check actually in total how much did I pay. You can see that in here we pay out 1,000, right? And then we pay it for 60 times, right? In this one, if we just like calculate roughly, the money that is out of our pocket is $60,000 for 5 years. But when we get the money back, we get $68,006. If you sum two of these terms together, you can see that we have $8,006.08. So what does it mean? This is interest amount that you receive from your investment. So that's why this one, okay, I just want to let you see that, okay, whenever we have like one amount of money, okay, for example, if we just like, we invest on the amount of money, at the end of the period, we usually comes back with the principal plus interest. So this one, future value here is the principal, plus interest. So where are they? Principal and the interest are here. Principal is 60,000, sorry, while interest is $8,006.08. So that's why this amount, the future value, comes to $68,006.08. Okay. Okay, then let's move on to the next example. The next example, I would like you to try on this function by yourself so that you'll be familiar with like how do I gonna set up the problems of like the financial function for you. Okay. So this is the second example. Okay. So in this one, okay, I would like you to find the future value by yourself. Everybody, please just like do it by yourself. I give you 3 minutes before I just like show you what we get. By the way, while you are doing on this problem, okay, I just want to tell you that on yesterday and a couple of days ago, I have to thank for some students who try to just like send me a line message and ask me whether we have class on today's class or not, or on Monday's class or not. The point that I found is that actually it is during this period of time or during this week, it is the rehearsal for the commencement ceremony. Okay, so some of my classes in Sky System was just like canceled automatically, while some of the subjects, okay, they were just like set up as usual. Okay, luckily that yesterday one of the students, one of your classmates, okay, just like send me a message to ask me. Then I go to check in the Sky and I found that it was canceled, and I didn't know before. Okay, thanks very much for telling me. So if you have anything like this, just let me know first so that I can just like clarify to you. Okay. Right. One more minute. Okay. So time's up. So to be quick for today's class, I just like want to show you the steps how to do that. And if you have any questions, just ask me, okay? But I mean, like when we go to like other functions that are just um like more detail, we need more detail than this. I'll just like let some of the volunteers to help us to do. Okay. Now let's see. For this problem, you are asked to find future value. So in this one, FV for sure. Okay. Investment, once again, is similar to the previous one, is investment. We would like to invest for $2,000 per quarter. Okay, $2,000 first. $2,000 must be the payment. When we pay out for investing, okay, we don't keep the money with us. It go out from our pocket, negative 2,000 as a PMT. So you type negative 2,000. Next, per quarter over 4 years. Per quarter, it means that 1 year we have 4 quarters, and we have 4 years. So it is 4 times 4. That is 16 for the number of periods. After that, with present value of 0, then PV is 0. Okay. Interest rate, once again, interest rate is 10% per year. We have to change to be the quarterly rate. If you remember, I always use this one so that it will be very easy for us. A circle is a year. 1 year has 4 quarters, something like that. So that means if you want to change the rate for per year to be rate per quarter, we divide 10% by 4. Okay, right. Okay, then in this one, the rate is equal to 10% divided by 4. Okay, it's 2.5%. Okay, or 0.025. Okay. Type we pay at the start of the quarter. The type is 1. So you can see that in here, the FV of future value, we will receive 39,729.46. So in here, let's see what are the principal and what are the interest. In here, if you see the principal, principal is like 2,000 times 16, that is 32,000, while the interest is 7,729.46. When you sum them up, you get the FV, okay, or future value here. Okay, right. So this is the future value, okay, that we need to know. So before I move on to the next function, do you have any questions? If you have any questions, let me know. Okay, right. Okay, everyone, do you still wake up? Are you still with me?
Still here.
Okay, thank you.
Yes,
Okay, thank you, Hap. I just want to hear my the lovely voice of my students, Hap. So please just say something. Okay, thank you very much. Okay, now let's go to the next function of this series. It's n per, or number of periods. Okay, so for the number of period or the n per function, you can see that in here. Okay, if you just like go to the function n per, okay, you go to formulas, financial, and then n per. It returns number of periods, okay, because n per is number of periods, right, of investment, okay, based on periodic, constant payment, and a constant interest rate. Okay, so this one is the same. We use the same assumption: constant payment, constant interest rate. Okay, periodic means that you pay just like in like different period of time, so we call it as periodic. And normally the period that you pay, you just like separate the period to pay equally. For example, if it is monthly basis, that means you usually pay every month. You don't just like pay 1 month number 1. I mean, let's say you don't pay just like on Jan, and then you skip to March, and then you skip to June, something like that. No, that is not periodic. So the periodic means that you divide the time equally, and you pay just like the time. I mean, for example, if you said monthly, it means you pay every month. If it's quarterly, you have to pay each quarter. You can't skip it. Okay. So in this one, what are the arguments that n per needs to have? N per need to use rate. Okay. PMT, PV, FV, and type. Be careful, the order from one function to another function is just like shuffle. It's not just like switch just a little bit, no. So you just like try to check the argument list or the argument order when you have to put or when you have to use the to use that function. My suggestion is that if it is a financial function, you may use like the function builder window here to help you so that you can just like enter all the values correctly. So the next one, okay. When we talk about this, the n per function here, everything is the same as like other, because you have to just like be careful about the rate, okay, about the rate that you have to enter, whether it's correct the duration or not. For the n per example, okay, we begin with this one. Okay, let me just like put in the chat box for you. Okay, now let's talk about this example. Okay, let me just like put all of the argument first. We have rate, PMT, PV, FV, and type. Some of you may have the question that why do I have to put like something like capital letters or small letters like this? Are there any difference? This is just like actually when you type it in the Excel, there's no difference at all. But I just like put them in the different letter case because when it is a function, I put them in the capital letters. When it is just an argument, because you can see that rate, PMT, PV, and FV, they can be the function as well as the arguments. So when they are just the argument, I put the small letter instead. Right. Okay. In this example, you are asked to find number of months. That means you want to know the time that you pay, or in this case, it is n per function, okay, or number of period function. So in this one, when we use or when we would like to use the n per function, we need this list of arguments. Okay. Now, let's talk about the problem here. We would like to require to pay off a loan, to pay off a loan. Okay. This one, it has a meaning too. When you would like to pay off a loan, that means once the loan contract finishes, you have no more debt. When you have no more debt, it means that future value must be 0 because you have no more debt at that time, right? So I put FB as 0 here. Okay. Then the loan is 50,000. When the loan is 50,000 means that when you borrow the money on the first day, the money is with you. When the money is with you, 50,000 is PV and it is positive number because you get the money from the bank already. Okay, I put 50,000 as a positive number here. Okay. Interest of 4% per year. Okay. But we want to know number of months. So you have to change the percentage to be interest per month. Then we divide 4% by 12 as the rate. 4% by 12. After that, okay, this one, let me put it as percentage. Next, you would like to pay 1,000 per month, means that you pay out 1,000 every month, so it is negative 1,000. And finally, the type, the payment is made at the end of the month. Okay, made at the end of the month. It is 0. Okay. After that, we put the function n per. We just put in here, I click fx and then I type n per. It's the same thing. Okay. Click OK, and then I just like start putting all of the arguments. When you see the intermediate result, the intermediate result in this example show us that it is 54.78. Can somebody tell me what is the unit of 54.78? 54.78 what? Dollars, year, quarter, month, or what? It's month, bin. Yes, it's correct. Because how does why do we get month, and why do we know that? Okay, 54 point something is 54 months. Thank you, Manit. The reason is because you try to standardize everything to be monthly basis, especially for the rate. This is the rate per month. That's why when you calculate for number of period tell us about number of months. Okay, right. So when we have this value already, if I click OK, let's try to understand this output or the answer of this NPER. So this one is 54.78 months, or I mean, like, if you just like say that if you want to round it up, you may say that it's around 55 months, or I mean, like in the problem, if you are asked, I mean, in the exam, that okay, how many months do you have to pay? Okay, you may answer, leave it like that, 54.78, or you may say that okay, you may round it. So how to round? If you remember, the round function is function equals to round. Okay, and then you put this number. You want 0 decimal point. It's round to be 55 months. And then you can answer. Right. So this is like the NPER function. So you can see that you have to just like adjust all of the things corresponding to the functions here. Then the unit of the NPER that we use to answer is will be corresponding to the rate that you use. If it is rate per month, NPER will be number of months that you have to pay. Right. So before I move on to the next example, do you have any questions? Oh, Pasut said that explain this question again. Okay, sure. So this one, number of months. So you are asked to find out period of time. So for the financial function that we learned, number of months is NPER for sure. Then we just like set up the argument for NPER function, that is this list of arguments. After that, we pay off a loan. If you pay off a loan, it tells us about FV must be 0. Okay, then you put FV as 0 here. And then interest rate, loan of 50,000. 50,000 means the original amount that you borrow from the bank. It's 50,000. But when you receive the money, 50,000 must be positive 50,000 because you get the money in your pocket. Okay. After that, interest rate is 4% per year. When we want 4% per year, when the bank charge you 4% per year, but we would like to find number of months, you have to change the rate to be interest rate per month first, so that they will be correspond to each other. So you will divide 4% by 12. Okay, that is 0.33% here. And after that, we say that we would like to pay 1,000 per month. Once you pay out of your pocket. So that's why the symbol is negative, because you pay out. And lastly, payment made at end of each month, it makes the type to be 0. So when you just like have like these all arguments already, you just like use NPER to calculate. Once you use NPER to calculate, you will see that we get 54.78 months here. But somebody said that, okay, if you have to tell the customers For example, if you are a banker and you would like to tell your customer that how long does this customer have to pay you, okay? Instead of telling them that you have to pay us 54.78 months, you may say that the customer has to pay around 55 months, or you may say that, okay, the customer has to pay us 54.78 months or around 55 months, something like that, okay? Also, is it clear enough? How do you know which type is correct? In here, normally they will tell you that, okay, when do you have to pay? Okay. Normally, if they don't tell you anything, the normal payment should be at the end of period. If they don't state anything, normally it's the end of the period. Because I mean, like, this is rule of thumb. When people would like to pay for the debt, okay, they will pay when they have the money. And normally, the day that they have the money as is when they receive the salary. That is the end of the month, okay, or the end of the quarter. For example, if they sell the product, okay, and they would like to just like pay the debt to the bank, they may say that, okay, they would like to just like have some more money first before they start paying to the bank. So that means they may say that, okay, at the end of the quarter, when I start having money or I collect my debt from my debt sheet, then I will pay to the bank. So normally, if they don't state that, pay at the beginning, okay? If they don't say anything, for example, in this question, if they say that, okay, if the question is like this, you can see that it doesn't tell you that when you have to pay, right? Assume that it's paying at the end of the month. Okay, this is the way that we do. Basically, in business, we always do like this as well. Okay, Pasud, is it clear enough for you now? Okay. Okay, นะครับ so any other questions for the first example? Okay, if you don't have any questions, the next example, please do it by yourself. Okay. Three minutes, please. Okay, then everyone, time's up. So can you please tell me how many quarters do we have to pay? If you get your answer already, can you please type 12? Okay. Okay, is it 12? Okay. Is it 12 exactly 12 or 12 point something? 11.9. Okay. Right. Okay, thank you. So let's see for this one. We do the same. We just like analyze the problem first. The first one, you are asked to find the quarterly payment. You are asked to find the quarterly payments. In this case, okay, that means you are asked to find the number of period for sure. Number of period for sure. Sorry. Here enter. That is quarterly. Okay. For this one, you would like to pay, excuse me, $1,200 to reduce the loan. Okay. $1,000 is the amount of money that you would like to pay. That is PMT, and you would like to pay. That means it is negative 1,200. So be careful about the symbol or the negativity or positivity of the payment. Okay, in here it is negative 1,200. Required to reduce the loan from 9,000 to 5,000. Okay, this one needs the interpretation or the analysis. You can see that to reduce the loan from 9,000 means that on day one you get 9,000 as a loan. You get the money from the bank. So present value is 9,000 in positive because you have the money $9,000 from the bank in positive. Reduced to 5,000 means that at the end of the period that we find, we still owe the bank for some amount of money. And in this one, it said 5,000. So future value, you still have money of the bank with you, 5,000. So that's why it's the positive number, 5,000. Type made at the beginning. So this one, when it's stated that it's the beginning, you have to change it to be what to say, type to be 1. Oh, I forgot the interest rate. The interest rate here said that interest rate of 6% per year. Then you have to divide it by 4 to get the quarterly rate. Okay. In here, the rate is equals to 6% divided by 4. Okay. After that, we just like calculate this NPER. In here, I use NPER function. Okay. So in this one, you can see that intermediate result show as like your classmate said it's 11.9, but it's not month, it's quarter. Okay. Or you may round it to be 12 quarter. Okay. Round. Right. Okay. So that means in this case, it's around 12 quarters that you have to just like pay to the bank, okay, to reduce the loan. Right. So any questions for this example? Okay, so if you don't have any questions, let me move on to the next function, that is PV. What is PV? PV is a present value function. Present value function. What is it for? Okay, let's go to see the PV description a bit. here. PV will return present value of investment. That means the total amount that a series of futures payment is worth now. Okay. For example, suppose you would like to invest on some money. Okay. You would like to know that, okay, how much does it worth now if you just like invest in that case. Okay. So we still use the same similar series of arguments that are rate and per, PMT, FV, and type. So the things that we have is that in here. Let's see the first example for PV, and then I'll explain the meaning of this problem first. So let's have a look for this example. This example asks you to find the present value, okay, of an annuity. So in this one, let me explain to you for the word annuity first. What is it? Annuity is a savings that we normally use to represent the saving in terms of, let's say, insurance. If you would like to save your money by using the insurance, instead of just like paying to the bank to save in the saving account, for the personal insurance, normally, when we just like would like to calculate, okay, that means in this one, it tells us that, okay, if the insurance contract finish, or if the insurance policy finish, for example, you may have like life insurance that if you pass away, your let's say beneficiary or the person who received the money, how much will they receive? Okay, so that's why we have to just like think of using the present value in here. We call it as annuity. It tells us about like the worth of the money that we have now if the insurance stops, okay, or finish its contract. So in this one, okay, for this present value here, we would like to know the PV, okay, of the insurance, what it's worth right now. Okay, so let me just like put all of the argument first, and then I'll just like try to fill up this argument with the values that it tells us in the problem. We said that in here, we want to know the PV of the annuity. The interest rate is 5% per year. Okay, is 5% per year. Let's see, we scan first. We pay per month. Okay, and we pay at the end of the month. So that means you have to change the rate to be monthly rate first. So in this one, I'll change 5% per year to be per month. So I divided by 12. So the rate is 5% divided by 12. Okay. It's around 0.41%. Okay. Next, payment, you do the payment $1,000 per month. It's the PMT. Payment you pay out, it is negative 1,000. After that, we say that over 5 years that we would like to pay. So number of periods is 5 years. Each year you pay 12 times, okay, monthly. So it's 60. And every for the annuity, okay, that means when you just like finish the contract, the FV is 0 here. And the type, okay, you pay at the end of the month is 0. Okay, right. Okay, so when we just like would like to formulate the FV, the PV, it is like this. Okay, we go to PV. PNG, FV, and type. So in this one, the present value of the annuity is 52,990.71. Okay, 52,990.71. Okay, right. So this is the present value calculation. In this one, I just like give you one example only because I mean in terms of annuity in here, we just like don't implement it in this class yet. Okay, for the details of the PV, you will learn more when we have to just like study for the business finance subject. Okay, so it will be like this. The meaning of the PV in here means that the value of money 52,990.71 is the current value of money for the annuity for the insurance that you have. If the insurance company say that they just like have 5% per year for you, and then you just like have to pay $1,000 per month. Okay, right. So that means suppose we just like talk about the present value here and the amount of money that you have to pay. Right? Let's see. We pay $1,000 per month for 60 months. Okay, that means actually you just like have 60,000. Okay, 60,000. But I mean like the present value here that you really have to pay to the insurance company is just like 52,990. Okay, right. So this is just like the thing that we have to think because they expect that okay for the insurance the condition is a bit different from the bank because I mean like for the bank if you stop paying that means your savings stop. But in terms of insurance, it's different because if you stop paying, if it is because you pass away, the insurance has to pay you that amount of money. Okay, we have to pay you that amount of money, right? For example, in here, you really have to pay up to 52,990. But if the insurance contract is finished due to the death of the payer, you are eligible or your beneficiary people are eligible to receive up to $60,000, something like that. Okay, right. So this is the PV or present value function. Okay. The next function that I'm going to talk about is the rate function. For the rate function or the interest rate that we need to know, okay, is that, okay, how much or how many percent that the interest rate is applied. What is it used for? Okay, let me just like show you the description of this function first, and then I'll just like talk about the application of the rate that you always see in the real life. Okay, for the rate function here, it returns interest rate for a period on of a loan or an investment. For example, use 6% by 4 for quarterly payments at 6% annual rate. In this one, okay, what are we going to use the rate function for? Normally, when you want to buy something, for example, if you would like to buy a car or if you would like to buy a house, okay, suppose you are planning that okay you can afford $1,000 per month. Okay, you can afford $1,000 per month, and the whole value of the car, let's say $40,000. Okay, so if you say that you have contract period for, let's say you would like to pay up to 4 years. Okay, how many percent will the bank will charge you? Okay, to get that amount of car. So in this one, when you have like we call this kind of thing as amortization table. It tells us that okay, if you can afford this amount of money for how long or for how many months, what car can you buy, or what what is the total amount that you have to pay, or if you have the total amount that you plan ahead, okay, how much do you have to pay, and how much will the bank charge you, something like that. So in this case, okay, we'll just like see the example first for the rate, and finally I'll just like compile all of these things together to let you see the amortization table later on. Okay, for the rate in here, if we want to know the rate that the bank will charge you, or the bank is charging you, or if you are the bank and you just like would like to tell your customers that this is the rate, interest rate that you will charge your customer, how are you going to calculate it, and what are like arguments that rate needs to have. In this case, the rate function needs to have this information. It needs to have N per, PMT, PV, FV, and type. Okay. So these are like the arguments that the rate need to have. But rate function has a special argument. Okay, before we stop, we close the parenthesis. The special argument is here. Guess. And then we close the parenthesis. What does it mean by guess? Guess here came from the past when the computer CPU was not as fast as it has in this period of time. You can see that right now when you calculate by using your PC, okay, or Mac, to use Excel, every time that you just like calculate anything, it seems to be just quick. You may say that I don't understand by quick, what quick it is. What do you mean by quick in here? Let me just like show you something. Everyone just notice on the circle that I have on my screen here. Okay, this one. You see that, okay, at the bottom left corner of Excel screen, you see the word ready, right? You see the word ready. Ready here means that right now there is no calculation that Excel is calculating for you. In the past, we needed to have this one, we call it as status bar. It tells the status of Excel, what is it doing. For example, if you just do this, if you double click on a cell, you can see that in here, Excel is showing enter. That means you are entering some values, okay, into a cell. For example, another example is here. If you just like go to another cell that you had like some calculation before and you double click on it, you can see that it shows the word edit. It means that you had functions or values before and you are editing that values. Okay. So this one helps the Excel users to know that right now Excel is ready for doing something or not, or what happened to Excel. Because sometimes when Excel is calculating something, once you try to click on some other cells, nothing's gonna happen. So that's why it has to tell you that the status here is ready or edit or enter, something like that. In the past, when the CPU was not fast enough, once you enter some functions and then you just like press enter to go to the next cell like this, Excel will just like start calculating or recalculating the things for you. So in this one, instead of having the terms edit, it shows like calculating. So you know that, okay, you have to wait. So how could you help Excel to process faster? Okay. For some functions, Excel may ask you for help. Okay. If you know some values ahead, please give the guideline to Excel so that it can just like process the data for you quicker. Like rate function here, you can see that sometimes, okay, if we just like use just the rate function, okay? And you just like start Excel to find out the rate for you. Excel will have to just like trying and trying until it see the rate that is matched with what you need. So it spends a lot of time in the past. So that's why Excel has an argument that is called guess. What is guess used for? Guess is used for just like giving some guideline to Excel to know that, okay, right now, okay, what value that you have in mind. If you know some rate ahead, for example, if you know that I remember that the rate like this should be around 0.2%, you just type 0.2% in the guess. So Excel will start by trying the rate that you put it as a guess first. If it's just like quite similar, Excel can process faster. But if you don't know, okay, and also in this generation of the CPU or the computer is fast enough, you don't need to put any guess anymore. But this function rate was like created for a long time, since the very first version of Excel, when Excel was like slower than this a lot. So they don't change the syntax, because there are a lot of like finance people who use rate function in Excel. That's why they still have to keep the argument guess, okay, for us. And bear in mind, even our our computer is faster than in the past. But if you have like, let's say, thousands of cells to calculate the rate, okay, once you open that workbook, it will be slow as well. So that's why sometimes you may need to use guess argument to help. Okay. Right. Okay. But if you don't know any values before, for example, if it is the first time to calculate the rate, just leave it as blank. So there is no problem as well. Okay. If you leave it as blank, or if you omit it, okay, if you omit it, Excel will think that you put 0.1 or 10%. Just leave it like that. Don't worry. Guess can be omitted, or you skip that value. Don't need to put anything. Okay, right. So in here, Excel needs to have PMT. Need to have PMT, PV, FV, type, and guess. Okay, right. Okay, in here, let's see the example that we need to find out the interest rate. What is it? In this one, okay, let me just like put the example for you. Okay, in this example, you are asked to find the monthly interest rate. So in this case, it needs to know the rate function for sure. Then I just like put all of the required argument first. If we type and guess. Oh, there must be like the input as well. Let me see. Rate function. Oh, input is the first one. Sorry. Okay, input. Right. So when we have this thing already, now let's see how do we gonna fill up this argument. In this problem, you are asked to find monthly interest rate. Okay. For sure, this one is the rate function. To clear a loan. To clear a loan means that in the future, our FV must be 0. Okay, because you want to clear the loan. So you put 0 for the FV. After that, the loan that is 50,000 means that you borrow the money from the bank for $50,000. So the loan that is 50,000 here, that is PV or present value. It is with us, so it is positive 50,000. Then you put 50,000 as a PV. 50,000. Payment of 1,000 per month. payment 1,000, so you pay. So 1,000 is the PMT, and it must be negative 1,000 because you pay out. Negative 1,000. You pay per month over 5 years. So that means N per, okay, is 5 years times 12 because it is monthly payment. So N per is 5 times 12. Okay. Type you pay at the end of each month is 0. Yes, we don't know. I leave it as blank. So the rate is here. We just put everything in its place. Start from N per PMT, sorry, PV, FV, type, and then guess. Okay, right. In here, I click OK. It returns as 0.618%. Okay, 0.18%, 618% per watt per month. How do we know that it's per month? Because we make the payment to be monthly payment. So that's why when we just like find the rate, it should corresponding to number of period or frequency of the period that you pay as well. That is 0.61% per month. Or when you would like to answer, there are two different ways to tell your customer. The first one, the rate is 0.61% per month, or you may multiply it by 12. And you say that it's the rate per year. Okay. This is the way that we may do. Okay. 7.42% per year. This is the yearly rate. Okay. So that means when you answer, okay, check first. Okay. In this case, the problem asks you for the percent per month. Okay, so that means you require to have the rate, that is percentage per month here. But you may just like have the alternative answer, that is or 7.42% per year as well. Okay, you just like put this one. Right. So before we just like talk about the next example that I'll let you do it by yourself, I just want to talk about the omitting of the values of it. Okay, so in this example, you can see that when I just double click on the cell that I have the calculation of the rate, that is on my screen is C88 here. You can see that we put all the arguments like this, and you can see that for the last argument, that is what to say, that is guess. I put cell C86 in here. When I put this is not omit. This is not equivalent to omit. So what will happen? In this one, if you have a look on the formula builder box, okay, you go to this cell, right, and then click FX. The formula builder box will show us in here. And then you can see that for the guess, it says 0. It says 0. It means that it is not omitted. You enter 0 in here. So how do you gonna put the value if it is omitted? What should we do? If you say that it is omit, okay, the things that we have to do is that instead of referring to the cell C86, see this, I delete it. This one equals to omit, because I don't enter any guess arguments at all. So the things that I enter as the argument, I put N per PMT, PV, FV, and type only. Okay, that are 5 arguments. So it's the same. Actually, the result is the same. But I just want to show you that if we omit, this is the way to do or the way to fill. if you have a look in here, in the guess, there's nothing here, means we omit it, right? So if you ask me, is it faster? Not much for this generation of your computer, because the calculation is quite quick, especially like in the exercise and in the exam. Okay, the time or the duration that Excel used to calculate is not much different. But in the reality, if you have like tens of thousands of cells to calculate the rate at the same time, you may see like the difference maybe just like 30 seconds or 1 minute in difference. Because once you press enter, you may have to wait for another 30 seconds before you can do another thing else. Right. Okay, then let's move on to the next example. Before we go to the next example, do you have any questions for the first example here?
I keep putting in the calculations and I'm ending up with 1% rate per month.
Yep. You get 1%, right?
1%, yeah.
Okay, the reason is because it's here. It doesn't show the decimal point. If you want it to show the decimal point, okay, you just go to right-click Format Cells and then add the decimal places. Here, it should show the exact percentage.
Okay.
Any other questions? Bear in mind, if you have to do the exercise and we have to do the, and we have to do the exam, the things that you have to do is that don't let it show as just like 1% like this. Okay. The things that you always have to do is that try to increase the decimal points, because percentage is quite just like sensitive. If you allow it to just like round from 0.62% to 1% is too much, then you should just like show the decimal points like this. Okay. So from Shanakan, you said that can you show rate per year formula? Rate per year formula here, I just multiply the rate per month by 12. Okay,ครับ Shanakan, do I answer your question,ครับ? Is this what you want? Okay,ครับ. So you just like times it by 12. Okay, right. Okay, then any other questions so far? If there is no question, let me just like move on to the next example. This example, I would like you to do it by yourself, okay, in 3 minutes. And then I'll just like talk about like the answer of this one. One more minute. Okay, then time's up. So class, can you tell me what is the monthly interest rate you can calculate? Can someone just type your answer in the chat box, please? How many percent,ครับ? How many percent for the interest rate? Zero point 0.33, 0.325. Okay, so you get like quite similar, 0.3251, something like that. Couple of things that I just like want to tell you is that, okay, when you record the percentage, like interest rate like this, the precision for 3 decimal point is okay, right? You should just like use up to 3 decimal points. For example, 0.325%, okay, or 2 decimal points are still okay, right? Okay, so you just like use 2 to 3 decimal points to record. But I mean, like, you may not like, suppose you try to answer like this. See the rate in this box. It's too much, okay? The precision should be just like 2 or 3 decimal points should be enough, not to be just like 10 or 12 decimal points like this, because it's too much, okay? All right. Okay, then a little more before we move on to, thank you for everyone who answered, okay, on this one. So you can see that you can calculate with a, to get the similar kind of the interest rate that is around like 0.325% or 0.33%, something like that. So now just a little more thing that I just want to talk about in this on my screen. You can see that when we see hash num and then exclamation mark in here, if it happened to be like the error like this, hash num, it means that there are some numbers are missing in the formula. For example, in here, if you see that, okay, what I did is that I copy everything from example number 1, and then I remove all of the values. Okay, so the rate still refer to the cells above, but in these cells we didn't have anything inside. So that's why it means that, okay, some numbers are missing. Okay, so that's why this function cannot calculate properly. Okay, so if you see the num error like this, you have to know that, okay, you have to just like fix the problem of like some missing numbers in your formula. Okay, now let's see. In this example, we would like to find monthly interest rate or the interest rate. So we have to use rate function in here. And then we would like it to return the rate in terms of the monthly rate as well. Okay. Now, this one said that we would like to save $20,000 over 2 years. $20,000 over 2 years means that at the end of 2 years, we want $2,000. Sorry, 2,000. So that means 2,000 is our FV, right? Because we want to save it in the future. So we put FV as 2,000. And it must be positive because we save the money. We want the money at that time. Okay, it must be 2,000. Sorry, 20,000. Okay. After that, over 2 years. It talks about NPER for sure, number of periods, and we have like we want monthly interest rate. Then we have to change 2 years to be number of months. So we multiply 2 by 12. Okay, that is 24 months. Okay. Investment of $800 per month. That means we invest per month $800 of PMT. And when we invest, we would like to put the money somewhere. So the money is out of our pocket for $800. So it is negative 800 for the PMT. Next. Payment made at the start of each month. So it's 1. Okay. And after that, PV or present value. You can see that in here, it doesn't say anything, but it said that we would like to do the investment. If we say that we invest on day 1, we don't have any money yet. That means it tells us that PV must be 0. Then you put 0 in here. And guess I omitted. So in here, you can see that the rate is 0.325%. Okay. Or you may round it as like 0.33. Both of them are okay. So this one, the unit of time is per month. The unit of rate is percentage per month. The reason is because it corresponds to the NPER that we have. Okay. Right. Okay. Or I can just like make it to be the rate per year as well. I multiply it by 12. Okay. It's around 3.9% per year, something like that. Okay, right. Okay, then this is the rate function that we have. Before I move on to the last function of today, do you have any questions for the rate function? So if you don't have any questions, okay, I'll talk about the next group of function or the next series of function that is called IPMT and PPMT and IRR. Okay, I'll start talking about IPMT first. Okay. For IPMT, okay, IPMT okay, and PPMT. These two functions, okay, are the functions that derive from the first series of functions. You can see that the similar thing is PMT, right? Okay, that's from the PMT function. So what is it? The formula is here. The formula here is PMT equals to IPMT plus PPMT. Okay, this is the formula. So what is it? For the formula here that we have, okay, PMT equals to IPMT plus PPMT. If you remember, when we calculate PMT, okay, when we calculate PMT at the very beginning of the financial function that we have, okay, you can see that, for example, the first example here said that the PMT is 943.56. That means for every month you pay equally 943.56. In this one, they pay in 5 years, that is month 60. We pay equally. If you remember, because I told you that we pay constantly. Okay, it's like this. So what about this formula? It means that every month you have to pay equally, but the proportion of IPMT and PPMT is different. IPMT, what is it first? IPMT is interest. Interest payment, while PPMT is principal payment or payment on principal. The same thing. So when we have the PMT or payment, okay, it's equal to IPMT plus PPMT of each period of time. So in each month, either in each month, even you say that we pay equally 943.56 here, but it comes from different proportion of the interest and different proportion of principal. So how is it? At the very beginning month, in this example, when you pay, if I say that I represent the whole box, okay, like this, as 953.56, 943.56. Okay. The things that happen is that at the very first month, the proportion of the money that you pay are interest, while the small proportion is principal. When the time goes by, when you pay 943.56 as well, but the proportion of the interest is smaller. This is interest. But the part of principal is bigger. Until the last month, you still pay equally. But majority that you pay is principal, while the smallest part is interest, like this. So that's why we may need to know that in each month that we pay, how much is the interest that we pay, how much is the principal that we pay as well. Okay, and when you just like sum them up for interest plus principal in each month, you get PMT. Okay, so this is like the basic concepts of like IPMT and PPMT. Now let's go to the formula for the IPMT or interest payment. In here, or interest payment here. I just like show you in the formula first. We go to IPMT to see the description of the function. This function returns the interest payment, okay, or for a given period of an investment based on periodic, constant payment and constant interest rate. The same assumption, but this one return interest payment on given period. So let's see the argument for the IPMT. What IPMT wants to have? It needs to have rate per N per PV, FV, and type. Now, there are like 6 arguments altogether. The extra argument that we have to know in this function is per. What is per? Per is period that you would like to know. For example, if we say that we would like to just like use or we would like to calculate the interest rate for period number 1, something like that, it means it's month 1. You can see that for the argument per here is a period of which you want to find the interest. Must be integer number 1 to N per. What does it mean? It means that if we say that the total period is 60 months, the possible period that you may put in this function is 1 to 60. 1 to 60, not more than that. If you put 0, it's nothing. If you put 61, it's error. Okay, because there is no period 61 anymore, as this contract is just 60 months, something like that. Okay, so in here, okay, now you know like the period argument that we have to use already. Let's move on to the example. The first example of the IPMT is this. Okay, I put the argument that IPMT need to use first. Rate per and per PV, FV, and type. So this problem, we said that we would like to find interest payment during month 1 and month 2 on a loan of 50,000 that is to be paid off over 5 years with interest rate of blah blah blah, something like that. Okay. Now let's just like understand this problem. In this problem, you are asked to find interest payment. That means it's the IPMT function for sure. During month 1 and month 2. Okay. Month 1 and month 2, this is per or period. So you need extra column for it. Okay, in here is month 1 and month 2. Okay, month 2 in here. Okay. On a loan of 50,000. Before I move on the loan of 50,000, on the first column, per is 1. Second column, per is 2, is for month 1 and month 2. Okay. On a loan of 50,000. So that means you borrow the money, 50,000 from the bank. So that means on day 1, you have 50,000 as PV. Okay, as a positive, 50,000. Okay. Next, you want to pay it off. So FV will be 0 for both of them. Over 5 years, it means that number of periods, okay, is 5 years, and you pay monthly because we have month 1 and month 2 in this one. So N per is 5 times 12 or 60 on both, equals to 5 times 12. Okay. Next, interest is 5% per year, and we talk about the monthly interest payment. Then the interest must be changed from 5% per year to be rate per month. That means you have to divide 5% by 12 to make it smaller. The rate is equals to 5% divided by 12. Okay, for both. Okay, it's the same rate in here. Okay, so next, payment made at the end of each month, type is 0 for both. Okay, here. So in here, I just like calculate the IPMT. Sorry, IPMT for each month. Let me just like calculate the month 1 first. I say that, okay, I go to IPMT, and then I just like apply all the arguments, rates, and per, rate per and per, PV, FV, and type. Okay. So you can see that the intermediate result show us that for month number 1, the interest amount that you have to pay is $208.33. The money is going out of our pocket, so it is returned as a negative value. Okay. Now we calculate the interest amount for second month. So you can see that in here, if we do the same thing, okay, I may copy the formula to refer the cell on the next column. It's $205.27. Now, if you want to know more, or if you want to test, okay, we will just do the things with other months in here. Suppose we have month 60. What will happen? Everything is the same except per. I will change per to be 60. So you can see that in here. It's 3.92. If you remember, I told you that the proportion of interest that you pay on the very first period, you pay a lot. And then it will be just reducing. It will be decreasing until the last month. You can see that you just pay $392 as interest. But don't forget, you still pay the PMT or payment in each month equally, but just the proportion is different. Okay. Now let me just try something that may cause some errors to this function. If you remember, I told you already that the per can be either from period number 1 to end per period. So that means the maximum period you can put is period 60. If you put period 61, what will happen? You can see that it shows the error because there is no period 61. You pay off the debt already, so that's why it is the error. Now, what about period 0? What will happen? Period 0 is also the error because there is no period 0. On day 1 that you borrow the money, you still have no debt yet. The debt that you start paying is when it reached the time to pay. That is the end of the first month. So that means at the end of the first month is month 1. Month 1. So then you start having the debt in here. Okay. Right. So bear in mind that for the per, okay, start from number 1 to end per only. Okay. Right. So this one is the first example of the rate. Okay. So the next example, would you please do it for me? Okay. I give you 3 minutes to calculate the interest amount for the second example. If you get the answer already, please type your answer in the chat box, please, so that I know that you finished already. Okay, 1 more minute. Okay, time's up. So who can find the answer already? Can you please type your answer in the chat box for me? Oh, it seems like no one finished this one yet. Okay, now, never mind, just see how to do this one, okay? For this example, okay, for this example, you have to find the interest payment that is IPMT, okay, during Q1 and Q2. So we prepare two columns, Q1 and Q2 here, and I put Q1, Q2 in the per. Okay. Next, investment current value of PV. Current value of PV is 0. Okay, this is PV. Required to reach 5,000 or FV for both. Okay, for over 2 years, 5,000 in the positive because we want to get the money, okay, as the what to say, investment. After that, over 2 years is N per. And you can see that because we pay quarterly, 2 years means that you multiply 2 by 4. Okay, it is 8 times that you have to pay. Type, you pay at the start of each quarter. You pay at the start of each quarter. It's 1. Okay, it's 1. Okay. Right. Okay. And the rate in here, we said that the rate is 3%, 3.5% per year. You have to make it to become quarterly rate. You divide it by 4. Okay, right. So this is the IPMT, okay, or interest that you receive. You can see that some of you might not sure that, hey, is it wrong? Why do I have $0? In here, it means that because the future value is not much. Hang on, the future value is not much. It's just 5,000. Okay, so that's why on month 1, okay, and apart from that one, you pay at the start of each quarter. At the start of Q1, you just start paying as the first time. So that's why there is no interest in Q1 yet. While Q2, you have the interest for $5 for just $5.26. Okay, and then you get more interest when the time goes by. Right? Okay. Right. So this is the calculation for the interest. Okay. On next class, I will talk about the principal or payment on principal that you have to pay, and then I'll combine them together to let you see how the proportion be just like deviated when the time goes by. Why is it positive? Money, what positive? You mean IPMT or what? Or FV? IPMT, because you invest. Interest means the interest that the bank pay you every time that you save. Okay, that's why it's positive. It's the incoming interest that you receive from the bank from the investment. And FV is positive because in the future you receive this amount of money back. Okay, right. Okay, any other questions for this example? If there is no question before we finish the class, let me just talk about this. Because on next Monday and Tuesday, it will be the commencement ceremony of your senior. Okay, so the reason why I didn't have the class cancellation during the rehearsal time is because actually we have just like the online class, so that's why you can just like stay home or in your place to just like have the class. but I mean for the commencement ceremony period, I would like you to just like if possible, you may have like friends or you may have like seniors that you want to congratulate them. So I think we can just like have the cancellation of the next class. Okay, we have the cancellation of the next class. So that means on the next Monday that the class will be canceled. The class will be canceled so that you can go to congratulate the graduate. And we will go back to see once again on next Wednesday. Okay, we will see each other again on next Wednesday. Shelin, there's no problem. I understand for the internet problem and computer problem. So that means we will see each other again on next Wednesday. And then I guess right now when you have a look on the exercises, you can do just like some exercises, some exercise only. Some of you send the message to ask me that, okay, what about HLOOKUP, VLOOKUP? When we finish this part for the financial function, we will talk about that part. We will talk about those functions. So that means if you see the exercise with the HLOOKUP, you can't do it now. Okay, just wait. Okay, then before we finish the class, everyone, would you please turn on your camera so that I can just like capture the screen. Okay. I hope that you just like spend your time like to just like practice on the exercise. Feel free to just like ask me if you just like don't understand for what questions, and if you just like want to ask me for whether it's correct or not. Okay, you may just like discuss with me. But I mean like after we finish the period of like the submission of the extra credit number 1 already, I'll just like post the answer for you. So everyone, okay, that should be all for today. I know that you have the class and then you need a break too. Okay, everyone, have a nice day and have a nice weekday and weekend. See you on next Wednesday. Bye bye, everyone. Take care and stay safe. Bye bye.
Thank you ค่ะ
You're welcome. Bye, everyone.
Thank you ค่ะ
You're welcome.
ครับ
Bye.
อาจารย์ครับ ผมลืมถามเมื่อกี้จะถาม
Yes,
ไอ้คือแอปเนี่ย
Sorry, Nat. Can you say again? I couldn't hear you clearly. The voice is breaking.
what is type ครับ
Type
Yeah.
is just like the argument to tell us that when do you pay the money.
when do you pay the money
We have like two possible way to pay: at the beginning of the period or at the end of the period. If it's at the end, it's type 0. If it's the
so if
beginning,
the at the beginning, so it will be 1, right?
yes, always. This is the argument that Excel function needs.
อ๋อครับ ได้ครับ ขอบคุณมากครับ
Okay, you're welcome. Bye bye.
ครับ